guys, it's ellipse and we are all over ellipse. This is a question you may not have understood in first glance, neither I had, but now I had figured it out and I put it forward so that you don't have to face such confusions. Directrix is given, eccentricity is given, focus is given. How do we find the required equation of ellipse? When directrix is given and eccentricity focus is given, then we can find focus is given 2, 5. Generally AE or only BE is given, but here AE and A part of AE and BE both are given. That means it has both H plus AE comma K or AE comma H plus K. So what we do, we go by the definition of ellipse. This is written. If you understand this, you will understand overall. What is this? This is distance formula. Distance formula. This is ellipse and this is foci S. This is point P XY and this is directrix. This is perpendicular length. And now what it becomes? This to this length of this SP square whole square, that is here square root is given, squaring, then square root is removed. SP square is equal to E square PM square. This is from definition of, by definition of ellipse. SP by PM is equal to eccentricity. Ratio of fixed distance and perpendicular length is equal to eccentricity. So this is equal to E square. This is perpendicular length. This is our perpendicular length because this is perpendicular on directrix. So these equations come forward, and solving this we can get the required equation of ellipse. Hope you enjoyed. Thank you. Stay tuned. Just a quick review from ellipse. This is one question of ellipse asked 57. The question says line XY is a direction ellipse. The point, the corresponding focus if the eccentricity be 1 by 3. Find the equation of other directrix. Equation of one directrix is given and other directrix is asked to calculate, and this focus S is given 2, 2 A and eccentricity is given 1/3. Equation of directrix, slope is -1, you can calculate, and this is perpendicular to this, so slope of this is 1. And now slope given, point given, we can find equation of this major axis. When we find this equation of major axis by definition of ellipse, what we have as z by SA by A to Z. This is locus. So it moves from S to Z. So SA by SZ is the ellipse. SA by AZ or ZA is the ellipse that is given. That is eccentricity is given 1/3. Here SA by AZ is equal to 1/3. Eccentricity is given. This is eccentricity, that is SA by AZ is in the ratio of 1/3. That means it divides in the ratio of 1:3. That is A divides SZ internally as well as externally, because this A is vertex and this A divides externally in the ratio of 1:3. And the coordinates we can found by using formula, internal section formula, external section formula. When this a is found, when the value of a is found, then we can find the middle point. We can find the middle point C, let z s comma z, and we can find by this point. Or we have found this point, we have found to be C. Center we have found 9/4, 9/4, because a dash, C lies between a dash. So this plus this divided by 2 and this plus this divided by 2. So we found the value of C. Also C is the middle point of z dash. So C remains same, and by using midpoint formula we can find the value of z s comma k. Z is equal to s comma k. That means z s comma k. Then we have s comma k. 9/4 is equal to, we have found value of s comma k, that is coordinate of z dash is s comma k, that is this z dash is s comma k. The second derivative is perpendicular, since this is parallel to this, so x, this equation was x plus y is equal to L, that is x plus y is equal to x plus y plus lambda is equal to this. Parallel. The equation is parallel. Now set the value of perpendicular by the value of lambda, and set the value of lambda is equal to this. Now we have put that the sum of the equation of the reciprocal of the perpendicular radius vector of an ellipse is constant. This is ellipse, and these two are radial vector CP and radial vector CQ R1 and R2. The angle theta and this being perpendicular to this. The question is ellipse. This is generally standard form of ellipse. Putting x is equal to r cos theta, y is equal to r sin theta for radial form. Then we put r cos theta and r sin theta here, dividing both sides by r square. And now CP is making an angle theta. So this is the form for radial vector R1 and the radial vector CQ, that is making an angle of 90 degree with this and this theta, that is 90 cos theta. Here 1 upon r equals same. This is same and this is same by 90 plus theta, and this is over this is same and theta. And from 1 and 2 we can just add 1 and 2, and we got the required result. Thanks for viewing.